methods of separation of homogeneous mixtures. What are homogeneous mixtures? They are the mixtures where the components are completely soluble and they have uniform composition throughout. The homogeneous mixture separation, first one is crystallization. That means formation of crystal. It is the process of formation of crystal. From where? From a saturated solution. So let us see. In laboratories, the process of forming crystal from saturated solution is called crystallization. And what is a crystal? Crystal is a solid that has a definite shape, that has regular geometric pattern. So it is a solid that is made of particles arranged in a regular geometric pattern and has a definite arrangement of particles, right? We can say they have definite arrangement of particles. So now it is said that if you take a saturated solution of compound B in water at 60 degrees Celsius, how? Preparing by dissolving 287 gram of B in 100 gram of water. So 287 gram of B plus 100 gram of water is being dissolved. I'm writing water. This one is water. Okay. What will happen if you gradually cool it to 40 degrees Celsius? So suppose if you cool it to 40 degrees Celsius and if by dissolving this you obtain a saturated solution, that means no more of it can be dissolved. If you prepare a saturated solution and then you heat it and try to dissolve as much you can, after that you are, I'm giving the heat sign here, after that you are cooling it. Okay. So here the temperature is kept at 60 degrees Celsius. Suddenly it is being cooled to 40 degrees Celsius. I will not use the term suddenly. I will say gradually. Gradual cooling. It has been cooled to 40 degrees Celsius. What are you going to see? You will see some solid crystals getting separated from the main solution. Crystal formation will be there because this is the method of crystallization, where you prepare a hot saturated solution of the homogeneous mixture and then what do? You filter it and then you gradually cool it. So we will see it over here. Some of the crystals of rock salt, candy sugar means misri, okay, and then frost is here. These are the natural crystals which you get to see. Now when you do this crystallization in the lab, how do you do it? What is the process? This is the activity which is in relation to it. First thing here, they are doing crystallization of copper sulphate. So copper sulphate, please do not touch it by your bare hands. Use gloves for the performance. You take 1 gram of copper sulphate, CuSO4. In one of the video I told you the formula, complete formula is CuSO4.5H2O, and you place it in 100 ml beaker. And to it you add 25 ml of water. That means a beaker that has a maximum capacity of 100 ml. To it, say you have added 25 ml of water and you have added copper sulphate to it, right? You have added copper sulphate crystals to it. Say these are CuSO4 crystals. I am just writing copper sulphate as CuSO4. Actual formula is this. Don't forget it. So copper sulphate crystals, how much I have taken? I have taken 1 gram. That much I have taken. And then I am just adding 1 drop or 2 drops of dilute H2SO4 acid. This is a mineral acid. Dilute H2SO4 is a mineral acid. So while adding acid, do it very carefully. Otherwise, tell your teacher to help you out. So when you are adding drops of dilute sulfuric acid, what is the need of adding sulfuric acid during the process of crystallization? Because sulfuric acid helps in making pure crystals by preventing unwanted reaction. Because sulfuric acid which you are adding, it prevents the hydrolysis of copper sulfate. So prevents the hydrolysis of copper sulfate. Now hydrolysis means CuSO4 reacts with water, it undergoes hydrolysis and it can give copper hydroxide CuOH whole twice as soluble impurity. Okay, so it can give you as this impurity. So in order to prevent the formation of any unwanted impurity, you should add dilute H2SO4, but in limited amount. Max to max 1 to 2 drops you can add. Do not add extra. If you add excess, then the medium will become too much acidic. As such, giving acid to it makes the medium acidic in nature, but slightly acidic in nature. If you add too much, it will increase the acidic level and it will damage the quality of the crystal which you are trying to find out. Then what do? After gradual adding of copper sulfate, the solution becomes saturated when no more of it is able to be added, and that needs to be done in the heated condition. And so now you have prepared hot saturated solution of copper sulfate. Okay, now after preparing the hot saturated solution, you need to filter it with the help of a glass rod such that it doesn't spill. And this hot saturated solution is filtered in order to remove insoluble impurity which will remain as residue in the filter paper, and you collect the clean solution in the beaker. This is not having any impurity. It's the clean solution which is cooled down gradually. It's a gradual process. Gradual cooling is being done. After some time, without disturbing the solution, that's very important. That is, cool slowly without disturbing. This is very important. What you will see? You will see shiny, sharp, well-shaped crystals, blue in color, of copper sulfate, and they have sharp texture. And you will get the crystals. You can filter the crystals, you can rinse them with cold water, and that also in filtration process only, and allow them to dry in a watch glass. So here, did you note one thing, that dilute H2SO4 is added? Why it is added? In order to make the medium slightly acidic, in order to remove any unwanted impurities, in order to prevent the hydrolysis of copper sulfate and prevent the formation of copper hydroxide. These all points are there. Next, one more thing, you have to keep in mind that you have to prepare a hot saturated solution of copper sulfate which you are filtering to remove the unwanted insoluble impurity, and the soluble impurity can be removed by allowing the filtrate. This is the filtrate, by allowing the filtrate to cool gradually. When it cools gradually, then you will get the sharp crystals, which you can again obtain by the method of filtration. You can wash it 2-3 times in the funnel only by giving cold water, and in the filter paper you will get these crystals, which you can transfer to the watch glass after cooling. Cooling means after drying in the filter paper. Now, 1 to 2 ml of saturated copper sulfate solution on a small glass plate. That means you can do in this manner also. You can take it in a watch glass or a petri dish. You take copper sulfate and you take water, less amount of water, and you heat it in a Bunsen burner. You are heating it, and then you will see that it is forming hot saturated solution. It is forming hot saturated solution, and then you can filter it same manner, and then you take the filtrate and cool it gradually, and then what you will get is the blue crystals of copper sulfate. But remember, while heating, while preparing, you have to add 1 to 2 drops of dilute H2SO4 for the same purpose. Okay, so it is a common technique for separation of pure crystals from homogeneous mixtures. Now think as a scientist, because scientists are obtained from schools, from homes, from fields like you people. Okay, so if a hot saturated solution of copper sulfate is cooled rapidly in cold water, in ice cold water, which is known as ice bath, ice cold water or ice is known as ice bath. Suppose you take this petri dish, or you take this watch glass, it is also known as petri dish. Okay, you take it and then you place it in ice. There is ice, blocks of ice, and you place it over here and say that okay, I want to cool it, so I want to make the process to be very fast. But will you actually get good quality of copper sulfate if you cool it so rapidly? Rapid cooling will actually damage the quality of the crystal. Rapid cooling will cause less quantity also. So rapid cooling is not suggested. Why? Because it gives fewer crystals and it gives poor quality of crystal. Okay, so that is not suggested. Now, refer to the solubility curves given in activity 5.2. We will go there. If equal masses of hot saturated solution of compound A and B are cooled at 2 different temperature, which solution is likely to deposit more solid? Higher temperature one or a lower temperature one? Obviously, which will give you a better quality of what? Solid. So same mass you have taken and you are cooling it at 2 different temperature. Okay, suppose I take this a mass, same mass I have to take at 2 different temperature. So that can be within this range only, because here we can see for compound B, suppose I take 241, this one. This is at a temperature 40, and then I am seeing what is happening at temperature 50. See, the plot is below, the point is below, right? So compound B, the solubility at a higher temperature is here for the same mass. So what if I keep the mass same and I increase the temperature? Why? The solubility decreases and you get a saturated solution. No more of it can be dissolved. Okay, that is how you obtain a saturated solution. Okay, so let us see. Here another thing. Will there be any change in the size of common salt crystal if the rate of evaporation is increased or decreased? Okay, common salt crystal, Yes, it will be. The rate of evaporation increased or decreased will actually cause the change in the size. The rate of evaporation should be done at a higher temperature in order to obtain a saturated solution. Obviously, if you cool from 80 degrees Celsius, it will give a good quality crystal than if you cool at 60 degrees Celsius. So temperature is one of the factor. So this is how you are showing how salt can be obtained from seawater. Seawater can be heated to form a saturated solution, and then it can be gradually cooled in order to obtain the salt crystals. And these are some crystals that we are seeing over here, naturally occurring crystals in caves and quartz. These are the naturally occurring crystals. Okay. Now, when we allow a solvent to evaporate to get a solute, such as salt, from a salt solution, the solvent disappears. However, we may also want to recover the solvent. What shall we do in that case? That is, suppose I want to heat it and I have a solution where the solute is here and I want to remove the solute from the solvent. Obviously, I will do evaporation to dryness. What if I want to collect these vapors and I want to get it again? I will put a cover, a glass cover, and I can obtain the water droplets by condensation. Okay, but if I have to separate two miscible liquid, how do we do so? For that, we need to do distillation, which will be discussed later. Now, crystallization of salt is an ancient process where by the local communities of the coastal areas in India, it was seen the panga salt was obtained by boiling concentrated sea brine. Sea brine means salt water, while evaporation of the sea water produced a salt which was karkach. Okay. Now the salt crystals of different sizes were produced by these methods. So ancient India used to follow crystallization in order to obtain salt from seawater, and it was obtained by boiling concentrated brine. Which salt was obtained? That is panga salt. And evaporation to dryness was done, and then the salt was obtained for karkach salt. So in the next video, we'll discuss about distillation. Till then, bye all of you.